Hi all, welcome to our YouTube channel. Today we are going to discuss about the topic Doubly linked list. This is our topic Doubly linked list. So, what is doubly linked list? A doubly linked list is a type of linked list in which each node contains three parts. This is one node. This is another node. In this example, we have four nodes. Okay, I will draw the one picture. This is one doubly linked list. Each node have three parts. This part is used to save the data. This part is used to save the address of next node. Okay, this part is used to save the address of the previous node. So in one node containing three parts, this for data and this field for storing the address of the next pointer, and then this field is used to save the address of the previous node. In this example here, B is the data, and that location will save the address of this node, and this location will save the address of that node. The first node have the address 1000, second node have the address 1004, third node have the address 1008, fourth node have the address 1012. Okay, so I will explain the value of the address field. So here this node have no previous nodes. So before that node there is no node. So the value in this field is none because no node has been referencing to that node. Here the address will be 1004, which means this node, this part will point to that this node. Okay. So what is the address of that field? 1000. Means this is the previous node of that node. So this part will save that 1000. 1000 is the address of this node. And what is the value of this field? 1008. 1008 is the address of the next node. Okay. So what is the value of this field? 1004. What is the value of this field? 1002. What is the value of this field? 1008 means address of the previous node. This is the current node and address of the previous node is 1008. What is the value of here? That is null because this node will not point to any other nodes. So the left node containing this link as null and right node containing that right link as null. Okay, so in the doubly linked list, we will save that left link and right link. Left link is the previous node address, and right link is that next node address. So that is the main concept we have to study in that doubly linked list part. So a doubly linked list consists of data part, next part, and previous part. Data in data part, the actual data of the node is saved. Here the data is 2. So actual data of the node is saved, and next part is a reference or pointer, the next node in the sequence. It will save the address of the next node. And previous is a reference or pointer to the previous node in the sequence. Okay, so the key difference between singly linked list and doubly linked list is that the doubly linked list allows traversal in both direction, means forward direction and backward direction, forward and backward, because each node has both the next pointer to the next pointer to the next node, and that previous uh, pointer to that previous node. These features make insertion and deletion more efficient at the both end of the list and enables easier traversal from the end back to the beginning. So we will traverse from beginning to last and from last to beginning using that two links. Okay. So what is the structure of that doubly linked list? Next we are going to discuss about the structure of doubly linked list. Head, tail, and node. Head is the first node of the linked list. Is the head in this figure? This is the head. This is the head node. Head node. Okay, we had mentioned as head, and then tail. Tail is the last node of the list. In this figure, this is the tail node. Okay, the tail node Right address is null. Head node, left address is null. Node, each node containing data, next and the previous address. This is a node, and this middle part containing the data. This right part containing the R-link. R-link means the link address of the next node. This is the L-link. L-link means the link address of the node address of the previous node. The examples of node in doubly linked list, the node uh, have that structure: previous address, data, and next address, next node address. Okay, means node have three part. This middle part save data, and this part save the next address, next node address, and this part will save the previous previous node data. Okay. So basic operation we will have to study in this topic: insertion, deletion, and traversal. Okay, so insertion means you have to insert the node at the beginning, insert node before the current head, and then at the end insert node after the current tail, and at a specific position insert a node at a particular position by adjusting a pointer of neighboring nodes. Okay, and deletion from beginning, remove the head node, and remove the end, remove the tail node, and remove a specific position, remove the node at a particular position. These are the important topics you will have to study in that Dublin English. And traversal, forward traversal, start from the head and follow the next pointer. Using that next pointer, you have to print the data in that linked list. Okay, and then backward traversal, start from the tail and follow the previous pointer. Using that previous pointer, we will traverse the entire doubly linked list and print the data. Okay, in the case of forward traversal, we will use that next pointer. Okay, in the case of backward traversal, we will use that uh, previous previous link address. Okay, so what next we are going to discuss about what are the advantages of double English. Is a bidirectional traversal. We can traverse both forward and backward, and efficient deletion, deleting a node specifically specially at the tail or from the middle is more efficient compared to a single linked list, since you have access that to the previous node, and then easier to reverse. Reversing the list is simpler since each node has a previous pointer. That's why we will easily reverse that linked list. So disadvantage of the double English are more memory, and each node requires extra memory for the previous pointer. We have to save. We are saving that previous node address. That's why we need an extra memory location. And complexity, operations such as insertion and deletion are slightly more complex due to management of both next and previous pointer. A doubly linked list is more flexible data structure than singly linked list, allowing for efficient traversal and operation for both directions. It has its constants, pros and cons, especially in the terms of memory usage and complexity of the implementation. But it can be very useful when the operation like deletion from both ends or reverse the traversal are required. So next we are going to discuss the C program. Here's the C program for doubly linked list that demonstrate how traverse the list and print the data. Okay. Next we are going to discuss about traverse the linked list and print the data. So I am explaining one C program, doubly linked list traverse. Okay. For that I am copying the code. You have to study that C program for your exams. Control C. I am using one online compiler. This one the online compiler. I had copied. Here we are traversing the linked list, doubly linked list, and print the data. Okay. So what we had done in this program, we have one, two, three, four nodes. Okay, four nodes. The data are 10, 20, 30, then 40. Then we had printed the forward direction and backward direction. The first example had shown us that data has printed using that nest pointer. Okay, and the second output had been showing that data has been printed using that previous node. Okay, so I will explain the code. First, we had used that two header files stdio.h and stdlib.h. Okay, and then one structure node. That node structure containing three parts: data part, nest part, and previous part. Okay, so the nest and previous are self-referential structures that are pointing to the same type of structure. Okay, and then using here we had used one node function, create node function. Okay, struct node star create node in data, and then using malloc we have allocated a new memory, struct node star new node equal to struct node star malloc size of struct node, and then we had added that data to that node, new node data equal to data, and then new node nest equal to null, and new node previous is equal to null. Okay, and then return new node. Who had called that function, we will return that node to that caller part. Okay, then first when we creating the first node, we had only saving the data, and here we have only one node, so that's why the next node containing the null address and the previous pointer are saving that value null. Okay, on the first node the next and previous value has null, and then we had used another function void append. This function is used to append at the node, and then struct node star star head comma in data, struct node star new node equal to create node of data. So new node create node of data, create node of data. Here we had called that function. On that function definition, we had creating one node, and then if star equal to head, then star head equal to new node. If the first node has not created, then that newly created node as a head. If the list is empty, the new node become the head, and then return the new node, and then struct node star last equal to star head, while struct node star last is equal to star head. The first node have that we had created one node, that node is the first node, then the first and last node have that same head, and then while last nest not equal to null, then last is equal to last nest. Okay, then last nest is equal to new node. New node previous is equal to last. This function is used to append the newly created node. Okay, I will explain the function definition. This print forward function is used to print the node. Struct node start temp equal to head, and then printf traversing forward, and while temp not equal to null, then printf uh, temp data and temp equal to temp nest, and printf null at the edge. Okay, and this function print backward struct node start head, and then struct node start temp equal to head, and then while temp not equal to null and temp nest not equal to null, then temp equal to temp nest, temp equal to temp nest. Then printf the traversing backward while temp not equal to null, then printf temp data, and then temp equal to temp previous. Okay, so we are using that link temp equal to temp previous for that backward direction. For the forward direction we had used temp equal to temp nest, and then at the end bring null. Okay, and the main function we had append star head comma 10, and then append star head comma 20, and append star head comma 30, and append star head comma 40. Okay. Then we had created that four nodes. Okay. I am adding one more function, 100,000, and I am running. Okay, so that 1,000 will added at the end of the linked list. In that forward direction, they had added that node had added in that the end node, end part. Okay, so the last node containing that 1,000. In the backward direction, the first we had printed the last node details. Okay, this is the doubly linked list. So on the doubly linked list, we had used that two links, previous and next. Using that previous link, we will print from backward, and using the next link, we will print from forward. We will print forward direction. Okay, that is the code part. So I am trying to explain that code. This function append is used to append the node. This function append is used to append the node. Okay, here we had passed the two arguments, head and data. Using struct nodes new node, using that create node function, we had created one new node. Okay, if the star head equal to null, means the head have node pointing to any other nodes. This is the head. Okay, uh, so that head will save that new node address. We'll explain. First, this is the header. Okay, HEAD. This is a newly created node. Okay, address 1,000. If the value of the head is null, means here there is no value had saved, which means there is no node at the time when we create that newly node. Okay, so here the value is null, then the newly created node address 1,000 will save here. 1,000 will save here. Okay, and then struct node star last is equal to head. So this is the friend, first, first and the last node, because we have only one node. Okay, so we had called the first node as friend and last node as tail. We had discussed on the previous uh, nodes. Head, tail, node. Okay, head means the first node of the list and tail is the last node of the list. And then struct node star last is equal to head. While last nest not equal to null, so last is equal to last nest. This is the part is used to traverse the last node. And then last nest is equal to new node. New node previous is equal to last. Set the previous pointer of the new node to that last node. Okay. So this is the code is used to traverse the linked list and print in forward and backward direction. This is the output. When we use that nest link, that is the output. When we use that previous node pointer, that will be the output. So the node structure, each node in the doubly linked has three field, data field, next field, and previous. Data field store the node value, next points to the next node, and previous points to the previous node. The create node function, a helper function that create a new node with the specific data and return it. That append function, a function that appends a new node at the end of the list. Okay, it check if the list is empty, and if so, the new node become the head. Otherwise, it traverses to the last node and insert that new node after it. Print forward function is used to traverse the list from the head to tail and then left to right and print that data of each node. And print backward function, first it traverses to the last node and then it print the data in the reverse order by moving backward using the previous pointer. On that main function, create an empty list head equal to null and append some nodes to the list. Then the calls that print forward and print backward function to print the list in both directions. Okay, print forward function is used to print the data in forward direction from left to right using next point. The print backward function is used to print data from right to left using previous pointer. Okay, that is the output. So forward traversal moving from the head to tail of the list using the next pointer. Backward traversal moving from the tail to head of the list using that previous pointer. So this is the main part of the code for that traversal. That is the code. This is the code for append the node. Okay, if the head field containing the null value, then this part will execute. Means before the insertion of new node, the head have that value null, then star head equal to new node. Okay. Else start node star last is equal to head, which means if we have one node, then we will traverse from left to right. That is the code. Why last next not equal to null? Okay, and then last equal to last nest. Okay, and then last nest is equal to new node. New node previous is equal to last. This is the code to insert the node at the end of the doubly linked list. Okay, append the node at the end. Okay, so if you have any doubt, please comment on that comment section. I'm going to stop the video. If you are not subscribed our YouTube channel, please subscribe and share to your friends. Thank you. Thanks for watching.